So this is our trigonometric polar form of a complex number. Okay, instead of x plus yi, we have r cosine theta plus I sine theta. This is the trigonometric form. Okay, we already did complex number form, x plus yi. This is trigonometric form. Okay, sometimes because we get tired of writing over and over, just like sine has been, shortened to sin, cosine is actually the word, this is cosine, but we say cos, tangent, we say tan. Instead of writing r cosine theta plus I sine theta, they sometimes shorthanded to cis. That means cosine theta plus I sine theta, okay? R is called the absolute value, or sometimes it's called the modulus. Don't worry about that a lot. They mostly refer to it as the absolute value, and theta is called the argument. We won't use that vocab a lot, but I wanted you to at least have it in case it is referred to in any of the book, or if I refer to it in the future. Okay, R is called the absolute value, and theta is called the argument. I want to express this in rectangular form. We want to be able to go back and forth from rectangular form to trigonometric form, just like we do in so many things in math, right? Sometimes we change, for example, square root of x. Sometimes we like it in radical form. Sometimes we like it in rational exponent form, okay? It's that same type thing, guys, okay? Sometimes I want to write a fraction as a half. Sometimes I want it in decimal form, 0.5. Here's we want to express this in rectangular form, which is x plus yi. Well, not so bad. Do you know what the cosine of 300 is? You should. 60 degrees short of 360, right? So the cosine of 60 is what? Half? What's the sine of 60? I'm sorry. The sine of 60, which should be the sine of 300. Seems like what am I in the fourth quadrant? So sine of 60 is square root of 3 over 2, but sine in the fourth quadrant is negative. So negative square root of 3 over 2. Let's distribute our 2 through. 2 times a half is 1. Plus, no, it'll be minus because that's negative. Plus a negative, I'm just going to write as minus I squared to 3, even though I know they have yi. Like we said, we usually write I in front when it's a square root. So there's a rectangular form. Not too bad, right? Let's go the other way. That's when it's a little harder. Okay, we have it in x plus yi form. X is negative square root of 3. Y is what? 1. So I need to know what r is. And I know that's the square root of x squared plus y squared. So that's the square root of 3 plus 1. R is 2, it looks like. Okay, so I have 2 times the cosine of, I need the theta. Well, remember from the other page. Oh, why did I go too far? No, I didn't go too far. Tangent of theta is y over x. So in this case, I know that the tangent of theta is 1 over negative square root of 3. If I rationalize that, that's negative square root of 3 over 3. I remember that's what? 30 degrees? Or pi over 6? Well, that's great, but am I in the first quadrant? My x is negative square root of 3, and my y is 1. A negative x and a positive y. I'm in the second quadrant. So in the second quadrant, that would be what? 5 pi over 6? Okay, so you have to be careful. So the answer is 2 cosine of 5 pi over 6 plus I sine of 5 pi over 6. Okay? Or I guess I could have written it as 2 cis 5 pi over 6 if I wanted to. Okay, really shorthanded. I could have written 2 cis 5 pi over 6, which means 2 times the cosine of 5 pi over 6 plus I sine of 5 pi over 6. Negative 3I. I might write that this way so I see that x is 0 and that y is negative 3. Okay, so r is the square root of 0 squared plus negative 3 squared. R is the square root of 9, which is 3. So I have 3 times the cosine of, here we go again, tangent of theta is y over x, negative 3 over 0, that's undefined. Where is tangent undefined? Right, at pi over 2, 3 pi over 2, or in other words, 90 degrees, 270. Well, where am I if x is 0 and y is 3? Go, 7, 6. 0, negative 3. Isn't that 270 degrees? Okay, I have to look where I am, which axis I'm on. So, sorry, I changed colors here. They wanted it in degree measure. So it's 3 times the cosine of 270 degrees plus I times the sine of 270 degrees. Another way to write that, again, is 3 cis 270 degrees, if you want to do the shorthand. Okay? My caution here is this thinking that, oh, I can't take negative 3 over 0, so I can't write this. And, you know, think about it. It's where is tangent undefined? Sometimes you will have 0 on the bottom. Okay? Now, here, I'm not so lucky. I don't have those nice numbers. Cosine of 115 degrees? Not sure. Okay, so they're saying that we can use a calculator approximation. So let's go to our calculator and take the cosine of 115 degrees. Cosine of 115 degrees, I got negative 0.422618. I'm going to stop at 4 decimal places, and in your homework in Schoology, I asked you to stop at that as well. Sine of 115 degrees. Let's see, that'll be positive, right? Yes, 0.9063 I. I'm going to put my I second, okay, since it's not a square root. Now I have to multiply both those by 6. So that gives me negative 2.536. I'm sorry. Plus, I'm going to take 6 times, I got 5.43. 5.4378. I was supposed to go to 4 decimal places, so I should again negative 2.5357. I said 4 decimal places. I don't know why I stopped at 3. 5357. Okay. I'm sorry. I'm having trouble writing. Okay. 5 minus 4i. I know that x is 5 and y is negative 4. It's just, I don't know what's happening to my pen. I'm sorry. I don't know what's going on. This Wacom tablet is, I'm going to whack it. So we have 5, negative 4. I just like to know where I am. I'm in the 4th quadrant. Okay? Tangent of theta is y over x, negative 4/5. When I do inverse tan of negative 4/5, I guess I'll stay in degrees. Inverse tan of negative 4/5, I get negative 38.659. I'm going to do negative 38.66. I think when you're in degrees, they said it round to 2 decimal places in degrees. Okay, that's great, but I don't want to write negative 38.66. I'm going to take 360 minus that. to get where I actually am here. 360 minus 38.66. That gives me 321.34. So I have R times cosine of 321.34 plus I sine of 321.34. I need my R, right? So R is the square root of x squared plus y squared, square root of 41. There we go. There's my trig form. Sorry that was so fast. Square root of 41, cis 321.34 degrees is the other way you can write that. Okay. All right. One place, an application of the complex number is something called a fractal, which you will study in college math if you go pretty far up. Okay. Just wanted to show you quick. Okay, you can look at that as much as you'd want. It's kind of cool. You have to admit, I think it's cool how that shape repeats and repeats and repeats and repeats. Okay, and that is that repetitive nature is that's where kind of art and there's a lot of math in art as well. Okay, that's something that you can find on page 369 if you would like to look at it further. Okay, I just wanted to show you a spot where it was used. Okay. That's it for 8-2.